Hello friends, Namaste, good day, Namaskaram, Sasriyakal, Abhivandana, Vanakkam. This is Team APS, Advanced Precision Systems. First and foremost, thanking you all for the support, likes and shares on our intro video posted last week. As mentioned, we are here with our model which marked the backbone of Bharat's prestigious moon landing named the Bahubali of ISRO, Indian Space Research Organization, the majestic LVM-3 Geosynchronous Satellite Launch Vehicle Mark III. ISRO's Chandrayaan-3 mission was highly successful and was duly acknowledged on the world stage in terms of our technological advancement to soft land on the moon. As we all know, Bharat stands titled the fourth nation to successfully land on the moon and the first nation to land on the dark side of the moon, which is on the moon's south pole. Before this, we shall take a look at the main pillars for the formation of our Indian Space Research Establishment, who laid the foundation stone for our space program, where they guided us through technological advancements to place us on the world rankings. The honor also goes to all Indian space scientists. We hereby present the model of the LVM-3, the prestigious workhorse and the Bahubali of ISRO. This majestic model was built as a still presentation for a science exhibition, and upon gaining requests from many young science enthusiasts to exhibit it to a higher level and present it as a working model, this was accepted and work was started to motivate young science enthusiasts. This was the story of building the model. Coming to its functionality, let me highlight you all on the features, timeline from build to completion, and also the next level updation which can be updated on the very same model. This model was built on a 10 to 15% D-scale ratio. The materials used for this project is a highlight, as 90% of it is from scrap material. The materials include plywood, aluminium, GI, paint and electronic hardware. Now, let me show you all around and brief you on the model. This is the deluge system, the transport trailer, the launch pad, 3 sets of swing-cum-vertically repositionable platforms, and finally the rocket LVM-3. This is the deluge system. It is built with plywood. This system is equipped with the built-in water-holding tank along with a submersible recirculation pump which can spray water in real time prior to the takeoff. The water spray system is disengaged at the moment for transportation purposes. This is the mobile launch pedestal. This is built with plywood according to the structure. Next is the launch pad with umbilical towers. The tower has 3 sets of swing-cum-vertically repositionable platforms used for servicing the launch vehicle during the last phase. The launch pad with the umbilical tower was a great challenge for us because we had to equip the entire rocket module, the support system, the repositioning platforms and functional hardware. So it was challenging to place every bit of hardware into this area, and which will act as a main command center for the model functionality. The total height of operation of lift is 2.5 meters from ground level. This is built with plywood, aluminium, extrusion guide channels and fasteners. The best feature of this is any future rocket assembly can be attached to this launch pad structure. The repositionable platform was built with GI struts, GI mesh blocks, pedestal mount systems. This is made functional with DC torque motors with controllers. Coming to the main highlight of the model, which is the rocket. This is built with PVC along with couplers and other fit-ups. The payload fairing is shaped with a mold to integrate it to the main body. The rocket is operated with slide track made out of aluminum extrusion channel and equipped with one pulley system, combined DC torque motor and a lift system combined with planetary motor working simultaneously with synchronized RPM. The operation is accomplished by a GI cable to maneuver the lift and drop system. Coming to electronic hardware, this is equipped with a basic DC motor controller with voltage regulators, which is used for easy operation. However, this can be updated to a higher level of integration for sequencing operation. The timeline from design to build and completion took approximately 48 man-hours. A few design permissible upgradation if required on the model. The mechanical upgrade for the lift track system can be updated to lift of the rocket. This can be extended up to 5 meters. The current height now maintained is 2.5 meters fairing tip from ground level. This was limited for transportation criteria. The electronic hardware is designed for an upgradation from basic switch mode to Arduino or Raspberry programming circuits. The system can also be integrated with multiple systems. Finally, we shall demonstrate the functional operation of the rocket. Hope you all like the content, and please do not forget to hit the subscribe button for more videos. Thank you, and signing off for now, Team APS.